diffusion of these ions affect the current response during the process? How does the system reach equilibrium after the voltage bias is applied, and what does it mean when the current response drops to zero? In a long-time approximation, when t much greater than L superscript 2 slash d, how does the relationship between the diffusion coefficient d and the current response I allow for the calculation of the diffusion coefficient? And why is this approximation used? What is the specific equation that approximates the relationship between the diffusion coefficient and current response, and how is it derived? Can Davis Zerns manufacture solid-state sodium-ion batteries made from seawater in Latvia? Why is it important to analyze the current response over time to determine the diffusion coefficient, and what does this process reveal about the kinetics of ion movement? How does PIT provide a deeper understanding of the electrochemical processes occurring at the electrode-electrolyte interface, and why is it an essential tool for studying ion diffusion in various materials used in energy storage devices? How is the diffusion coefficient calculated based on the voltage response in electrochemical systems, and what role does this calculation play in understanding ion movement in electrode materials? What is the significance of the pulse current duration, and why is a 10-minute pulse current followed by a 60-minute disconnection used in the voltage response process of the Co0.85 say and SZ-RGO electrode? How does the voltage response process change over time in the Co0.85 say and SZ-RGO electrode, and what can be inferred from this response about the diffusion behavior of ions? What information can be obtained from observing the voltage response during the pulse current duration and the subsequent disconnection period, and how does this contribute to understanding the kinetics of ion diffusion in the electrode material? How does the charge/discharge process of the Co0.85 say and SZ-RGO electrode relate to the chemical diffusion coefficient of Na+? And what does it reveal about the movement of Na+ ions in the electrode during these processes? What does the term chemical diffusion coefficient refer to, and how is it related to the movement and behavior of Na+ ions in the Co0.85 say and SZ-RGO electrode? Why is it essential to analyze both the charge and discharge processes when calculating the chemical diffusion coefficient of Na+, and how do these processes reflect the nature of ion diffusion in the material? How does the Co0.85 say and SZ-RGO electrodes performance during charge and discharge cycles help in determining the diffusion coefficient of Na+, and what does this tell us about the material's potential for use in energy storage devices? How do the voltage response and the charge/discharge processes collectively provide insight into the effectiveness of the Co0.85 say and SZ-RGO electrode for applications requiring efficient ion diffusion?